Okay, today in the sack we have a very nice Ameritron AL-811H amplifier, and it's in quite good condition, but it needs a few things to be done, and from a few checks that I have done, it needs four things basically. The first is to enable uh, the 10 and 12 meters band, which is in the aux position. There are already the components in there, so I think this mod is going to be easy. And the other one is the 160 meters shows too much as WR, so I think this needs to be tuned. And we're going to install a flashover protection for the vacuum tubes, the 4, 8, 11 vacuum tubes. And I think that, and we have to replace also a grid resistor, but we're going to replace all 4 grid resistors. So I think these 4 modifications will make the amplifier very useful again on 160, 10 and 12 meters, add protection and replace the faulty parts. Okay, first, now we are inside the amplifier, but first I'm going to check for high voltages in all the parts here, because the amplifier has been used in the previous days, so there might be some residual high voltage there. So I'm going to switch on the power and the operation switch here, and I'm gonna check for voltages in the anodes and the rest of the parts of the power supply here before I do any modification. And here are the 4 grid resistors that you see, and I have already replaced one faulty resistor in the previous attempt to test if the amplifier will work. It did work, but I have much nicer resistors now to replace. I have bought some Dale resistors, 2 watt 51 ohm Dale resistors here. So I'm gonna replace all of those 4 resistors. So here are the 4 new grid resistors installed. The original ones were wire resistors, and they were about that size for comparison. Those are rated for 2 watts, and those are 2 watts as well, but those are metal film resistors. I don't know if it's the right thing to put to replace the wire resistors in the grid with metal film resistors, but I think that grids don't like the extra inductance, so I think it's a much better solution to put there lower inductance resistors. The best way is to put these resistors underneath the chassis, close to the tubes, I think, and there are some internet sites that prompt you to do so, but I wanted to leave the amplifier as it is and just replace the faulty parts. And since the cost of 4 resistors is not much, so I replaced all 4 of them. I have now performed the flashover protection for the tubes and the rest of the components of the circuit, and I'm using the advice of Papa Alpha Zero Fox Romeo India from his website, but I modified a little bit the scheme, the way that the components were soldered. So here we have the power resistor, which is soldered directly below on these PCB trays, and then it goes to all the way above the diodes, and it's soldered to a fuse socket, and there is a small hole that you have to make here to hold the fuse socket, and there is a big cable that connects it back to this point. And there is a small bed, ferrite bed below this point, which normally connects this point to that point. So he removes this bed here, and he relies on the inductance of this wire resistor to do the job of the bed. Now, I don't say it doesn't work, but I think my way is better here, and I have performed it in a much more, much less wiring, and I think it's better, it's much better. So what I have here is this bed, which is below that thing, below from this to this point, below the PCB. I have just connected it at the top side of the PCB and soldered in its original pad at the top side. And then there is a small piece of wire which connects to the fuse holder. Now below this there is already a hole and a screw which holds the PCB. You can see it from below. I don't know if you can see it. It's this one here. This shaft here ends up on this place on the PCB. So what I actually did is I used this hole and the screw and just mounted the fuse here. So I don't need to do any extra holes here, and if anyone in the future needs to undo the modification, it will leave no traces. And we have much less wiring. If you compare this wire to this wire, this red wire here, that's much less wiring. And with this method, I reuse the bed also. So the bed is there for a reason. I know that the resistor being inductive can do the job of the bed, but there's there for a reason. So I reuse this bed. Then we have this big resistor again, and I have actually not soldered at all in the trace here in order not to leave any trace on the PCB. I have just unhooked unscrewed this screw and used another washer and hooked this resistor mechanically there. Yeah, it might be better to solder it onto the PCB, but a best way would be to use one of these solder slugs here and insert this slug and solder the resistor onto it. I didn't want to use just the trace of the PCB to mechanically stabilize this big resistor. So I think this way it has turned up much better, and it leaves less traces, and the modification can be easily undone in the future. And we also reuse this bed here. Much better way, I think. Another thing that I wanted to mention is that I have used a fuse socket, a fuse holder with this protective plastic. There are fuse holders that have this protective plastic above, and the reason for doing so is that this fuse could blow. I mean, it could literally blow. The glass could blow away and smash into many pieces. So imagine having a blown tube here without a protective glass and a protective case, and have all this glass to be scattered all over around the amplifier, and with the airflow, some of these pieces may end up also in the outlet of the amplifier and into the environment. So why not having just a fuse with a fuse holder with a protection cover? So that's the other thing that I did here. Now back on the tuning circuits, the input tuning circuits, my amplifier seems to have the 10 meters already installed. We're gonna perform a tuning later on by tuning this slug here, the 10 meters slug. It's already connected. There's no ground anywhere, no wire to cut. It's already installed. But the 160 meters has a problem, and I've managed to find actually this problem. I was having a high SWR on 160 meters. So that's the inductor of 160 meters, and any of these inductors is connected to this blue switch there, the selector switch. So this is a two wafer switch, a two parts switch. I don't know if you can see it nicely here. There are two parts here that rotate. right? Depending on the bands. You see the gap there? You see this little gap? There are two parts on this switch. It actually selects the input and the output, so it really isolates each of the tuning circuits here, of the PI circuits here, the LC circuits. It isolates it completely when it isolates any actually circuit, any filter completely when one of these is selected. So I used the multimeter, and I've managed to find that this coil is shorted to the switch, to one contact of the switch, one of these two parts, when it switches to 160 meters, but the other part stays open. And with a little bit of inspection, I've managed to find that the problem is a little contact there. No, I don't know if you can see it. It's really hard to see it there. It's this contact, this contact here. It's a little bit out of focus. But when I switch to 160 meters, actually this disc is it's bent a little bit downwards at that point, and it does not make a contact. So I'm gonna fix it, bend a little bit the disc upwards so as to make a contact on 160 meters, and then I think it will be all okay. And I've actually done it. I've used a little tool and bent this on 160 meters, and it did made contact. So that's the problem. I'm gonna fix this one, and then I'm gonna close the amplifier enclosure and hook it up to the radio and tune these circuits here. Maybe the 160 meters does not need any tuning, but I think the 10 meters does. So I'm gonna do this next. Okay, that was it. The amplifier is working fine in all bands, 160 through 10 meters. And I have tried it. I'm not trying it out in the camera now. It will take quite a lot of time to tune and test it, but I have tried it, and I can show it to you on 160 meters. Sorry, on 40 meters. So here we go. Okay, with a drive of around 40 watts. So that was it. This project was completed. I hope you enjoyed the little modifications that I did and learned something about repairing this nice linear amplifier. Thanks all for watching. Here is Sierra Victor 3 Oscar Romeo Alpha. Thank you. 73.